Okay, our new topic is exponentials and logs. So an exponential is just another way of saying an index or power. So we are going to begin with revising all our index laws. So I've written the 8 down here. So you can write them out and revise them in your book, and I'll go through a couple of examples on the next page. Okay, so this first example, so the rule is if you have a power outside the brackets, everything inside, every power inside the bracket will get times by it. So this one becomes x to the power of 6 because 3 times 2, and this one becomes y to the power of 4. Okay, with the next example, now we can only add if they're the same bases. So if we have a look, we see that they're not. So the first base is 3, second base is 9 and 27. But what we can, and we need to be able to start seeing, is that 9 could be written as 3 squared. So I've just changed 9 to be because it's 3 squared. Now we can't forget about this squared, so that's outside. And I can change 27, that's the same as 3 cubed. You'll get used to the numbers and you'll remember the powers once you do more of them. So now for my next line, I'm going to get rid of the brackets. So timesing it out, that'd be 3 to the power of 4 and 3 to the power of 9. Now when we're timesing indices of the same base, we add the bases. So it ends up being 4 plus 4 plus 9. So that equals 3 to the power of 17. Okay, so once again in this last example, we need them to be the same base, and you hopefully can see 25. So you know that's 5 squared. So then hopefully you can remember then, 125 is 5 cubed. As I said, you get used to these numbers and you'll remember them. So let's multiply the powers out. So I've got 5 to the power of 9 over 5 to the power of 4. Now this is essentially like saying dividing. So when we divide by the same base, we subtract. So we get 9 minus 4, so we get 5 to the power of 5. And there's our answer. So with these next couple of ones, I'm not saying that it's not the only way. There's lots of different ways that you can do them. So maybe you might see it differently to the way I saw it, and that's okay, but hopefully we all get up to the last answer. So with this one, I'm going to get rid of the brackets first. So everything inside the brackets got times by the power. So remember, a -2 by -3 became a +6. And I'm doing the same down the bottom. It'd be +4 and +2. Now, it's up to you what you want to do, but I'm going to go across the top. And because we're like timesing here, we can add things of the same base. So I'm going to have, a2 power of 2 plus a to the -3, so that's going to be a to the -1, and then b, that's like a power of 1, so it'd be 1 plus 6, so b is 7, and then I've still left the bottom. Now, because I know that the bottom is like dividing, so the rule for dividing is we subtract, so I'm going to subtract 4, and b 7, and subtract 2. So then my answer B is a to the -5, and b to the power of 5. Now, we often like to have positive integers. So let's put it down. So I can put the a down the bottom, and that becomes a positive power. Positive powers. And so there we go. And that's a positive. Not saying the one above is wrong, but you'll probably see the answers like this. Okay, in this next example, the bottom number of a fraction is, if you remember, we could write, so first of all, I could write this like this. 243 to the power of 1/5 and 3 outside. Because if you think about it, if we had powers outside, we'd multiply out, so we'll go back to that. So we can write that like this. Now, if we have 1 over 5 to the power of 1 over 5, that can also be written as the 5th root of 243. And then I can just leave the power of 3 out that. So if you do the 5th root of 243, it actually is 3. So you can do that one on your calculator, or soon you'll remember. And then, so then, because the answer to this is 3, and then I've got a power of 3, and then I can do that. So I know 3 to the power of 3 is 27, and there's my answer. So here, in this next one, we can do the same. So I said, all right, it could be written as 32 1/5 times outside -2, because if I times that out, I'd get this. So then I change that to the 5th root of 32 and -2. Now, the 5th root of 32 is 2. So if you went 2 times 2 times 2 5 times, you get 32. So I now have that is 2 to the power of -2. So if you have 2 to the power of -2, we like to make it a positive number index. So we'll put it down the bottom, and then obviously 2 squared is 4. So you can leave it as a quarter, and there's your answer. Okay, with this example up the top here. So if I left the x minus 1 squared, and I can say, now instead of writing square root, I can say that's the same as saying x minus 1 to the power of a half. Because the power of a half is the same as the square root. Now if you look here, we have the same base. See, that's a base, and that's the same base. So if we're multiplying and there's the same base, we add the powers. So I can say that that is x minus 1 and 2 plus a half. Okay, so then you have to be able to be good at your fractions, but obviously 2 is 4 over 2 plus 1. So you get x minus 1 to the power of 5 on 2. And there's your answer. Okay, now with these next ones, we might do them a bit later on, but we'll do them now. So we want to look at, if we've written here, we've got 4 to the power of x. Now 256 is actually 4 to the power of 4. So if you know that that is 4, these are the same, then therefore this must be x must equal 4. So you get it so the bases match, and then the top powers must equal each other. So over here in this other example, so if I've got 2n minus 4, 3 to the power of that, we want to get this side to be the same base. So we know though 3 to the power of 0, because anything to the power of 0 is 1. So I could write 1 as 3 to the power of 0. So if I do that, that means I can say that 2n minus 4 equals 0, because they're the same. So we get 2n minus 4 equals 0, and you get 2n, and I'll keep rearranging, positive 4, n equals 4 over 2, n equals 2. We'll do more of these later, but just in case you get some. Okay, and then the last one, when you've got these big ones, just take it slowly and do step by step. And as I said, you might see it's something different, but so I'm going to change these square roots to powers of a half. And this one, because it's 4, it's actually 2 to the power of a quarter. Okay, all over 16 to the power of 3 on 4. All right, so, and then I might change that 16 to the power of 3 on 4, I might change that to being 16 to the power of a quarter times 3. Okay, so, and then we keep going. So we've got 3 quarter. I'm not doing anything with these at the moment. There's no matching bases, but the 4 power of a quarter could be the 4 cubic root, and that is actually 2. So I can get 3 to a quarter times 6 over a half times 2 over a quarter, and I can get this to be 2 to the power of 3. Now that these are matching bases and it's like they're dividing, we can work them out. So I've got, I'm not doing anything with the 3 and the quarter times 6.5, yeah, times 2 to the quarter over 2 times 3. Now, what I could do is I'm going to try and change this 6 to something. So really, 6 could be written as, so I'm just copying them, but I could write 6 as 2 times 3 and a power of a half. And that's the same thing, isn't it? So, and then I could pretend that they had a power of 1, and then you expand that out. So really I get 3 to a quarter times and 2 to a half times 3 to a half times 2 to a quarter, so they're all there, over 2 times 3. Now I have things that are similar bases, so I'll deal with them together. So the 3's are the same base, so you're going to have 1/4 plus a half times 2, and I'm going to have a half plus a quarter, and all over 2, 3. I'm just going to tidy up as I go. So 1/4 plus 1/2, that's 3/4 times, and same 3/4, sorry, over 2, 3. And now I can do the 2's because that's like dividing. So I get 3/4 times 3/4 minus 3, which would equal 3/4 times 2 3/4 minus 12 over 4. And running out of room. Let me get. Okay, so we're left with 3 to the power 3/4 times 2 to the -9 on 4. But we don't want a negative index, so I'll put the 2 down the bottom to make it a positive 9 on 4. So you could, there's different stages, you could have done different things, but hopefully you'll get to the end. Just take your time and check your work.